my leg now. Like, I have arthritis.
All right, here we go, guys. So we've done Raymond Sums. We've done 3 of the top Raymond Sums, LRAM, MRAM, RRAM. What is a Raymond Sum? Area underneath a curve, an infinite amount of rectangles. If you don't have rectangles, you do not have a Raymond Sum. If you just see sigma notation and it's not width times height, it is not a Raymond Sum. We understand that, right? Yes. If you just see sigma and it says k equals 1 to 5 or infinity, it doesn't matter. It could be infinity as well, to n, and limit of n approaches infinity, and you just see I plus 3 or k plus 3 and that's it. There's no delta n or anything else. Is that a Raymond Sum? No. A Raymond Sum is infinite amount of rectangles, literally adding up each rectangle. Does that make sense to you guys? You need to see the delta x. You need to see the delta x, whether it's n approaches infinity or you have a finite number of rectangles. Usually they test you with finite number of rectangles. So yeah, there's one more. Trapezoids. Relax. Are you guys pretty happy with trapezoids? You guys remember trapezoids like this. Do I start with yeah, let's do a question. Okay, yeah. You guys remember trapezoids like this. Is that how you guys remember trapezoids? Yeah. I'm trying to draw a normal one. There we go. Our trapezoids are going to look like this. Child, that's not a trapezoid. The area changes. The triangle's not in there. It's not embedded. It's the same formula. The only difference, it's like, okay, if we call this, what do they call that? Base 1, base 2, that's height. So what is area of a trapezoid? You guys remember? Base 1 plus base 2 times. That will give you can use that as well for this one. Base 1, base 2, there's your height. Chav, why is it the same? Well, first of all, it's the same because you don't have this extra stuff for B2, so it's not going to affect it. We can do a proof. I've done a proof in the past to show that they're equal, but trust me, it's the same formula for both. Now, would I memorize the trapezoidal formula, this one right here that you're going to see? I'll tell you what I've told classes in the past. I would not memorize that formula because usually they ask different width anyways, but most of the students have, but you don't have to memorize anything because it's really easy to remember, but it's very easy to derive it. So by the way, our trapezoids are good. Did I already tell you guys that our trapezoids look like this? Okay, our difference is that our h usually is the delta x. So our trapezoids are going to be standing up. Child, can you give me an example? I'm a visual learner. Relax, I'm going to do visuals. Of course I'm going to do visuals. So if I have a curve, and let's say I have 3 trapezoids in here. So notice I'm going to draw boom, boom. I'm going to put 2 trapezoids. Is that okay with you guys? So here are my 2 trapezoids. Do you guys see them? Cool or not cool? Where the bases are my y values. Y0, y1, y2. I'll do one more trapezoid. It's sideways. I'll put it right here. Your delta x is that height there. So it's standing up. Do you guys see it? Yeah. So right now I have 1, 2, 3 trapezoids. And I'm going to write that as y3. Now check it out. Look what happens if I were to, and I'm going to call this h. I'm going to say all the h's are the same. So I'm talking about the distance from here to here. So if I were to expand this formula, so let's say I want the area. So I'm going to write area, approximate area, right? And how do I find area of a trapezoid? I'm using that formula right there, right? Base 1 plus base 2. But I don't call it base 1. I'm going to call it what? Y0. So I'm going to go y0, y0. And then plus y1. And then I'm going to, I guess let me put that in little parentheses because I want it to look like the parentheses. Times height divided by 2. That's my first trapezoid. Do you guys agree? Plus, and then my second trapezoid, number 2, what's that base here? Y1 plus the next base is a y2 times my height divided by 2. Plus, what about that third trapezoid? y2 plus y3 times height divided by 2. What can I factor out from each trapezoid? H over 2. So look what happens when I factor that out. H over 2, parenthesis. And I'm just going to drop the parentheses there. Y naught plus Y1 plus Y1 plus Y2 plus Y2 plus Y3, close parentheses. What do you notice? Do you see how you have two Y1s and two Y2s? So now check this out. Look how beautiful this is. H over 2, Y naught plus 2Y1 plus 2Y2 plus Y3. OMG, look at this formula and look at the formula they gave us. Is it not the same formula? Don't worry, I'm going to zoom out to it. It's the same formula, guys. Now, we're going to do a whole bunch of free response questions. Usually, I'm trying to remember, usually every free response questions that I have seen, I want to say at least 90% of them, 90% of the free response questions that I have seen that have told you to do trapezoids have had different quote-unquote heights. So, so I would just do each individual trapezoid. Does that make sense? Now, if the heights are all, so that's why I'm telling you, you don't have to memorize this formula. I would just say no area of a trapezoid, base 1 plus base 2 times height divided by 2. Because then even if the heights are all the same, you can just use this formula, you'll still get the same answer. Does that make sense to you guys? So I'm not going to necessarily emphasize this formula, but I guess sometimes I will. I'm like, oh, the heights are the same. Let's factor it out. Notice that the endpoints does not have a 2 in the front. That's all. So if you have 3 trapezoids, you need 4 points. If you have 4 trapezoids, you need 5 points. If you have 5 trapezoids, you need 6 points. So however many trapezoids you have, you need 1 more point. Cool? See? Like I have 3 trapezoids here. 1, 2, 3. How many points did I need? 1, 2, 3, 4. By the way, in this one, is it an over or under approximation, the way I drew this one? It's an under because the trapezoid's like just barely below the curve. Oh, it just depends. I think it depends on concavity. If you're concave up, like this, then your trapezoid is going to be, let me exaggerate it. See? So that trapezoid will be just a little bit over. So you can see that the accuracies are getting better now. And maybe, I think for the future, next year, I think I'm just going to introduce them all at the same time. Instead of this year where I did L, M, and R. I think next year I'm just going to do them all. Do you recommend we should do that next year or not?
No, I feel like the LNR lesson was a lot. So.
Okay, so
Maybe.
Yeah, we'll see. Everything else is the same, guys. The height is still the same thing, or that's just for delta x. So what is that? So they do tell you that LRAM plus RRAM divided by 2 is the same thing as your trapezoid. So yeah, and you can see that algebraically, but don't worry about that until we get to it. How do we feel? All right, so let's see. Let's just use it. So it says use trapezoidal rule with n equals 4 to estimate the area under the curve from 1 to 2 of x squared. Compare the estimate with the exact value. Oh man, we haven't talked about exact values. Darn it. Okay. No, do I want to ruin it for you guys? Okay, we'll see. I don't know. We'll decide right now if we want to ruin it or not. All right. X squared between 1 and 2. Here's 1, here's 2, and it looks something like that. I want to use how many trapezoids? 4. So that means if I want to use 4 trapezoids, that's 1 right there. So 2 minus 1 divided by 4. So each trapezoid has a delta x or a height of 1/4. Do you guys agree? So let me see if I can put it in here. So here's my visual, and I'll zoom in. So I need this point, I need that point. There's my first trapezoid. Oh man, it's going to look like it's right on the line. It's not, but I just suck at drawing. Can you kind of see the concavity there? It's just slightly over. And we're going to call that 2 right there. Because it's concave up. x squared is concave up, so when you do a trapezoid, it's going to be just a little bit over. If you want to exaggerate a concave up curve, you know what I mean? Okay. Are we okay, guys? All right. So here we go. Do you want to use the formula, or should we just calculate each trapezoid by itself? Yeah, let's just do each one by itself. All right. So I already know that my delta x is going to be my height. So there's your delta x, which is going to be the height of each trapezoid. Cool? So I'm going to label the trapezoids just for good notes. Trapezoid 1, trapezoid 2, trapezoid 3, trapezoid 4. Trapezoid 1 has an area of, well, let's see. Let me label the x-axis here. This is 1.5, that's 1.25, 1.75. Okay. Has an area of, let's see, base 1 plus base 2. The height of that base is determined by the y value, and the function is x squared, right? So it's going to be 1, let me put parentheses, 1 squared plus, you're going to need a calculator, 1.25 squared, close it. The height is 1/4, so I'm just going to put it as 0.25 since everything's in decimal. And I'm going to divide that by 2. Yes. Oh, because that's the length of the base. The base is determined, that's the length of this trapezoid. Trapezoid number 1 looks like this, miss. And this is the y value squared, you know what I mean? Did I answer your question? Yes. Okay. So there's area number 1. Someone do that one for me, somewhere on the side. Area number 2, you're going to do 1.25 squared plus 1.5 squared. This is x squared, right? Times 0.25 divided by 2. Someone do that one. Area number 3, you're going to go 1.5 squared plus 1.75 squared times 0.25 divided by 2. And area number 4, finally, 1.75 squared plus 2 squared times 0.25 divided by 2. There are times that the formula is probably easier to use than doing this by hand every single time. But yeah, do that. Does someone have the area number 1 for me? Yeah, let me show you guys how to do it fast. Type this into y1. So I'm going to go to my calculator here. Y equals, I'm going to put x squared. So there's my x squared. And yeah, I think I agree with this one that maybe it is easier to do with a formula. So check it out. Do you see how every single point repeats itself except for the endpoints at 1 and 2? So then I would go, so here's my formula, using formula. I'm going to put it in blue. Using formula. I'm going to write 1/4 divided by 2, so that's our 1/8. And I'm going to go y at, where did I start at? 1? Y at 1 plus 2 times 1.25 plus 2 times 1.5 plus 2 times 1.75. And then the last one does not have a 2 in the front. Yeah, I forgot the y naughts, I know. 2y.
Oh, that's the
Yeah. Mm-hmm. There's a y after the 2. And then this one just goes y of 2. Close giant parenthesis. Let me try to, there's that big one, there's that big one. Yeah, well, I mean, it's going to take some time. So don't worry necessarily about speed. It's going to take time anyways. With the old one? Right. Oh, just for the first one? Or the whole thing?
No, for the whole.
Okay. Let's see. And you didn't do it with the formula, right? You did it like add them up by one at a time?
No, I did it with the formula.
Oh, okay. It's fine. Let's see. So 1/8. Here's my 1/8. 1/4 divided by 2 is 1/8, right, guys? Giant parenthesis, and then I'm going to go alpha trace, enter, and then we started it at 1, plus the next one have a 2 in the front, so 2, alpha trace, y1 at 1.25, plus 2, alpha trace y1 at 1.5 plus 2 alpha trace y1 at 1.75. And then my last coordinate does not have a 2. It's just alpha trace y1 at 2, right? And then close the parenthesis. That closes everything. 2.34375. Yay, we did it, guys. 2.34375. Say it again. Yeah, I put the equation into y1. And those are my bases, right? You guys know? Okay. So we're okay with that, guys? Okay. So let's continue. How do you guys feel with that? Do you guys feel okay? You're gonna, what's up? Oh. You guys want to know how to do the exact value, but it's gonna ruin it. Oh, that's my fault. All right. So here we go. Save it.
Yeah.
Okay. How about I just give you the number? Okay. The number is. Okay. You know what? I know how I can do it without messing it up for anyone. You see this right here? Does everyone agree that means area under the curve from 1 to 2 of x squared? Okay, so I know how to do it without ruining it for anyone. I'm going to type this into the calculator, and do you guys agree that whatever that number is the area? All right, so here's my calculator, and I'm going to go, there it is, there's my x squared. It's easy enough to type in x squared. Math, number 9. Look at that, I have a little integral. I'm going to put 1. I'm going to put 2. I'm going to type in x squared in here. I could also type in y1, but there it is so you guys can see it. Now everyone agrees that this is going to give me my area, right? So look, I haven't messed up the magic. You'll see the magic later on. This is my exact area. Let's turn it into a fraction. Oh, that's fine. 2.333. Look at the answer that we got. Look how close it is. Are we surprised? Let me see if we are. Are we surprised that this one's bigger than the exact? No, because it's just a little, each trapezoid is a little over. Does that make sense? And there it is. I haven't ruined the surprise.
I just did it once, by the way, and we got the same thing.
Perfect. Thank you, miss. How do we feel? By the way, just because you learned that new trick with the calculator, don't be using it right now, guys. We're not professionals yet. Okay, let's go to the next one. Now I kind of feel bad for you putting examples with equal subdivisions, but oh well, that's fine. Okay, you guys, we're just going to use the formula for these, but I do feel bad. I just emphasize not to remember the formula, right? Make sure you know how to find area of one trapezoid. It says on the interval -2 to 4, if 3 equal subdivisions are used, what is the trapezoid approximation? Okay, let's find our delta x, which is going to be our height. So let's see, 4 minus a -2 divided by how many trapezoids? 3. So that is 6 divided by 3, so it's going to be 2. So my height of each trapezoid is 2. Are we still okay? All right. So here we go. I'm going to write 2. I'm using my formula. Using formula. And the only reason I'm using formula is because I have what? 3 equal subdivisions. So put that in there. Only because I have equal subdivisions. 2 divided by 2, parenthesis, giant parenthesis. My very first coordinate, do I have a 2 in the front? That's the height, and then the bottom is part of the formula. And then, so here we go. E to the -2 over 2. Is anyone confused? I have to start with the leftmost point on the interval. And then, what am I doing? Plus or minus? Or plus or multiply or minus or what? Plus, and put a 2 in the front. That 2 is because there's 2 of them, right? From both, okay. Times e to the what? No, not -1. The delta x, or the height is 2, to the 0. No, it's all good. over 2. So we could have even factored out another 2 in the bottom there, but that's fine.
Why is it 0 again?
The delta x is 2. So we're moving left to right. So negative 2 plus 2, we're at 0, plus 2. My next coordinate, plus 2, giant parenthesis, e to the, oh, actually, how many times? Oh, yeah, we're good. We're still good. Second, over 2, close it. Okay, let's see if you guys know. What about the next one? Perfect. Do I put a 2 in the front? No, the endpoints do not have the 2. E to the over 2. Close it, close it. Are we okay? All right, I notice, I'm looking at the answer choices. None of them have any fractions or a denominator in the front. I am tempted to, do I see any 2s? Yeah, I do. I am tempted to factor out a half. And I say half because I don't, yeah, I know what you're saying. You're like, Chavez, why don't you just cancel it? But I don't see a 2 in the front, like in the front term or the last term. Does that make sense to you guys? So can I factor out a half? When I say factor out a half, I'm trying to factor out the 2 in the denominator. Okay. Yes, cancel that out. So if I factor out the half on all of them, so here it is, half. So now I have e to the negative 2 plus 2e to the 0 plus 2e squared plus e to the 4th. Does that make sense to everyone? Okay, now don't get confused. That 1 is not the height, and that 2 is not the same 2 as dividing by 2. That comes from what we factored out. All right, let's look for that. Is it in there? Which one is it? Yeah, that's all good. Yeah, it is deep. They just felt like writing it different, try to trick people. How do we feel? Yeah, so I'm going to exaggerate this graph. You see this graph? So maybe you're a visual. So I'm going to exaggerate this graph. Where do I have space? So I'm going to write it right here. I'm going to zoom in and then see if I can. So here's that graph exaggerated. Negative what to negative 2 to. So here it is, and I'm exaggerating it, miss. So the trapezoids I did, here's negative 2. And I'm going to say, actually way over here, that's fine. I'm going to say that's, you know what, let me write the negative 2 over here.
I think I did it now.
Are you sure?
Yeah.
It's all good, miss. I already started, so we're good. Negative 2 to 0. There's my first trapezoid. And then there's my second. And I only have 3. There's my third. See? And what I did was I just factored out each one had a height of 2. So I really just did this. I used this formula because they had equal heights.
So let's say if the fusion x was 3 minus e to the negative 4 plus 2 times e to the 1.
If delta x was 3, which was my height, yes.
Okay.
Cool? Are we feeling okay, guys? All right. So here's a question. Let me see. This one looks like it comes from UH as well, but don't quote me on that. The function f is continuous on the closed interval 1 to 7 and has values that are given in the table below. Is that the next one? Yeah. Using subintervals 1 to 4, 4 to 6, and 6 to 7, what is the trapezoidal approximation of 1 to 7 of f of x dx? Perfect. So on this one, this is more realistic. Do I have trapezoids of equal heights? No. The delta x is the heights, guys. Are we okay with that? All right. We don't. Bless you. Bless you. Bless you squared. Look at this height right here. The distance between 1 and 4, what is that gap? 3. So right in here, write change in x, which also equals your height, is going to be 3 for that one. Do you guys see that? What about between 4 and 6? So the change in x, which also equals your height, is going to be 2 for that trapezoid. And then what about between 6 and 7? So your change in x, which equals your height, is going to be 1. So we're going to have to do the trapezoid formula no matter what, 3 different times. Cool? All right, here we go. So base 1 plus base 2. This is the y value is your basis. Remember, my trapezoid is aiming upwards. So we're going to go 10 plus 30 times the height, which is what? Divided by 2. There's my first one. Plus, yep, we only have 3 trapezoids. That's why we need 4 points. See? Plus, what's my first base for the second trapezoid? 30 plus 40, and I'm going to multiply that by the height, which is 2 divided by 2, plus, what's the next one? 40 plus 20 times 1 divided by 2. Okay, here's a hack. Oh, it is only works on free response, and I'm going to tell you in advance, the professors hate it because I hear them grumbling all the time. If you are prone to making mistakes, this is full credit on free response only. And the professors have no choice because they're hired by College Board, and I'll hear like, oh, they didn't finalize. But, and I hear them, but they have to give you the points. They have to give you the point, that 1 point for the answer. If you are prone to making mistakes, you can leave it like that. Now, don't leave it like that in multiple choice, guys. Multiple choice, if you don't answer the question, you don't get the point. But for free response, as long as all the numbers are filled in, for free response, this would be considered an answer. Okay. So I'll tell you whether to, I would like for you to continue, but if I continue, like let's say I'm going to grade all 3 of your mock exams, and I'm going to have notes on all of you. If you always make algebra mistakes, by mock exam 3, I'm going to tell you, leave here, please. So, and if you're strong and you don't make mistakes, I'm going to tell you to continue. But, yeah, the rest is just arithmetic. Do you know how to add, subtract, multiply?
Yeah, the rest is not even algebra.
Yeah, it's just like, do you know how to add and subtract? All right, so there it is. Now let's go ahead and see if we know how to add correctly. 30 plus 10 is 40. 40 divided by 2 is 20, and 20 times 3 is, so we can do that. Plus, the 2's cancel out right here. What's 40 plus 30? 4, 5, 6, 7, 70. Plus, let's see, 40 plus 20 is 60 divided by 2. There it is, and then add up those. So 70 plus 30 is 100, plus 60 is, there it is. How do we feel, guys? Okay, awesome. All right. Then we'll do a little review here. So I think the best way to do a review is to do visuals. Don't worry, we're going to go slow. If a function f of x is strictly increasing, so underline that, from a to b, and you do an LRAM with equal subdivisions, LRAM will produce an underestimate of the actual value. This is exact. So underline this, or circle that, and put that means exact area. All right, let's do a strictly increasing graph. Let's do concave up and concave down. Concave up, and then concave down. I'll do it over here. Oh, remember when we covered Raymond Sums, and we said the number of rectangles approaches infinity, and then we said that the sigma notation means this integral? Yeah, so that means exact. So I'm just gonna put like 2 rectangles in here, guys, with LRAM. So let's see. LRAM and then LRAM. Is that a true statement that that LRAM will give you an underestimate? Yeah. So these are just notes for you guys. So again, this one says strictly increasing again from A to B, and we're doing an RRAM. So do the same thing: concave up, concave down, and we're doing RRAM. So RRAM, RRAM, RRAM. So will RRAM give you an overestimate? Yes. I don't know why it does that. Okay, now I have strictly what? Decreasing. So draw a decreasing graph. Do one concave up, do one concave down. So decreasing graph, concave up, decreasing graph, concave down. And let's see. We're doing, this one's LRAM again, so leftmost point. And I want you guys to observe. I just put 2 rectangles, LRAM. So does an LRAM give you an overestimate for a strictly decreasing graph? Yeah, it does. You can see plainly does the visuals help, or I don't know? Okay. All right, let's do the next one, strictly decreasing again, but we're doing R round, so do both concavities. So decreasing concave up and decreasing concave down. R ram. So we're gonna go and then R ram. Does it give you an underestimate? Yes. That'll just review. All right. And don't worry, why didn't we include trapezoids in there? Because trapezoid, not only does it depend on increasing, decreasing, it really depends more on concavity. But LRAM, RRAM just depends, like you can see. Cool or not cool? Zoom out? Yeah. No, I just put both. If I'm increasing, I just decided to put both. But if we were to do trapezoids with an increasing graph and we do concave up, concave down, that would not, like, it would agree, it would not be like this one. See how on this one, we can talk about it real quick. See how on this one, let's look at this one, let's focus on that one. So on this one, concave up, increasing, concave down, increasing, but LRAM still gave me an underestimate. Do you see that? But if I were to do trapezoids would disagree on both. So let's do it real quick. Don't worry. You don't have to write this down. You can just listen real quick. I'll do it right here in the bottom. So here's an increasing, concave up. Here's decreasing, concave down. If I do a trapezoid, I'm going to exaggerate it by putting one big trapezoid. So here's a point. Here's another point. So what is that? An overestimate because it's a little bit above the curve. Do you guys see that? But now look at this. Point, point. I exaggerated it there, but what is that one? Under. So that's why I didn't talk about the trapezoids for this, because on this, no matter what, they agree on both of them. But on trapezoids, what matters is the concavity. On LRAM and RRAM, what matters is, are you increasing or are you decreasing? Does that make sense? Okay. All right. I don't know if we're ready, but I feel like we can maybe be ready. Do you guys want to see if we can tackle a free response question from a real AP exam? All right, so I don't remember what year it is. I have it saved in my notes. Let me see. Notes 29. What's the title? I'll tell you right now what the title is, guys. Notes 29, 06BQ6. So that means 2006. Let's give College Board credit. 2006 Form B. Question 6. What was that? What was that? A fart? It sounded like one. Okay, sorry. Are we okay so far? Okay. Question 6 is always no calculator. Actually, as a matter of fact, question 3 to question 6 is no calculator. I think in 06 it was question 4, 5, 6 that didn't have calculator. But for sure, question 6 have no calculator. Are we okay so far, guys? All right, let's first dive into this world and see where are we living. Like, what's the problem here? So they give me a time, and it looks like 0, 15, 25, 30, 35, 50, 60. It doesn't look like they're equal subdivisions. They give me V of t. What is that? Velocity. They even put the units, feet per second. And they gave me A of t. What is that? Acceleration. Feet per second, or feet per second squared. And they give me numbers. Example 4. A car travels on a straight track. So we don't have to worry about turning. I'm just going on a straight track. During the interval 0 to 60 seconds, so during this time interval, the car's velocity v, measured in feet per second, and acceleration a, measured in feet per second, are continuous functions. Okay, yeah, that's true. The table above shows selected values of these functions. All right. Letter A, using appropriate units, explain the meaning of integral from 30 to 60 of absolute value v of t dt in terms of the car's motion. Okay, so before we explain anything, I guess let's keep reading, right? Approximate the integral using a trapezoidal approximation with 3 subintervals determined by the table. Okay, I think we can do one of these two for sure. I think we can do this one. And I think we can probably also figure out what it means, but I think for sure we can calculate that. Didn't we just learn how to do trapezoids? All right, so it says absolute value. So that means turn all these into positives. 20, 30, 20, 14, 10, 0, 10. Okay, so in your head, you don't have to do this, but in your head, imagine x, y axis, and you just have points in quadrant 1, just random points, these random points. You just have something like this. Point, 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 point. And what are you going to do? You're going to do trapezoids between those 2 points like that. Point, and you're going to do another trapezoid. I think they said 3 trapezoids, right? So that's all you're doing. So they wanted three subintervals determined by the table. Okay, here's 30, here's 60. So here's my first trapezoid between 30 and 35. Do you guys see that? I'm going to call that number 1. Between 35 and 50, that has to be trapezoid number 2. And between 50 and 60, that has to be trapezoid number 3. Are we okay so far? All right, here we go. Area of a trapezoid, base 1 plus base 2. What's going to be my first base? 14, no? Okay, so I'm going to do this, guys, because we always want to answer the question. So we're going to go 30 to 60, absolute value of v of t dt. And I'm going to put the approximate symbol, but you can put the equal symbol. And we're doing trapezoidal approximation, so here we go. 14, parenthesis, 14, plus, what's the next one? 10, and I'm going to multiply that by 5. Does everyone know where we're multiplying by 5? And divide all that by 2. That's the trapezoid formula, guys. Base 1 plus base 2 times height divided by 2. Everyone okay so far? Okay, let's go to the second trapezoid. Plus, what's the second one? What am I going to use for my first base? 10 plus 0 times what? 15, the difference between 35 and 50. 15 divided by 2 plus, what's the next one? 0 again, plus 10 times 10, 50 to 60, 10, all divided by 2. If you're scared, can you leave it like that? Yes, that is, whatever that is, that's the answer. That really is. They probably have the answer key with a number, but if you're scared, you can leave it like that. If you make mistakes, leave it like that. If you're running out of time, leave it like that. Cool? I think we're strong. Should we try it? See if we can add it? All right, let's see. You can now put an equal sign because now you're just adding up all those things. Let's see. 10 plus 14 is 24. And I can do 24 divided by 2 pretty quick. 24 divided by 2 is 12. And 12 times 5? So I can do that. We can do that. And then I would not bother with 10 times 15. What I would do is 10 divided by 2, which is 5. And then 5 times 15 we can do. 15, 30, 60, looks like 75, right? Let me know if I'm wrong. I make mistakes all the time. 15, 30, 60, 75. Yeah. Are we okay so far? All right. Then the next one, it doesn't matter. Whatever you want to do. 10 divided by 2 is 5. 5 times 10 is 50. Or you can do 10 times 10 is 100 divided by 2. I think either way on those you can do. All right. Let's see. Can we do that? I would do 60 and 50, which is 110 plus 75. I want to say it's 185. And I need units. So let feet per second times second. What is that? I don't know. Feet per second times second is... No. Feet per second times second is not feet per second squared. Feet per second. So put it here on the side. Feet per second times second. It's just feet. I'll put FT, feet. All right, let's see if we can answer this question though. Using appropriate units, explain the meaning. What do you think this means? That's right. This is the distance traveled, not the displacement, but it's the distance traveled between t equals 30 and t equals 60. And don't worry if you don't get it, we need more experience. This is the, or you know what? Let's answer the question. Oh no, yeah, we are answering. What does it mean? Using appropriate units, explain the meaning in terms of the car's motion. Okay, so it says, since it says using appropriate units, I'm gonna say the car traveled 185 feet. The car traveled a distance. Make sure you say the word distance. A distance of 185 feet from t equals 30 to t equals 60. You can also say on the interval from t equals 30 to t equals 60. I think that sounds better. Seconds, period. So car traveled a distance of 185 feet from t equals 30 to t equals 60. I think it sounds better if you say the word interval. The car traveled a distance of 180 feet on the interval from t equals 30 seconds to t equals 60 seconds. I think that sounds better, but this will give credit to. We'll see the key in a little bit to see how it really looks. I haven't seen the key yet, guys.
Explain. Alright, so do we have to explain why it means that?
No, that's good. It doesn't approximate. Nope. That's right there is full credit. Absolute value of velocity is speed, and area under the curve of a speed curve is distance traveled. How do we feel? In a little bit, we'll see the rubric, and we'll see what it says. Letter B. You think we can handle letter B? Using appropriate units, explain the meaning of integral from 0 to 30 of a of t dt in terms of the car's motion. Find the value. Ooh, we're not ready for that. I mean, they want the exact, which we can, but we haven't tied it together yet. So put in here, not ready. I think I gave you guys this notes too early. Like 2 days too early. Because we had to talk about the fundamental theorem of calculus. So we're 2 days too early with these notes. Yeah. What number is this? Did we have notes 28 already? Okay, I think I was way too ambitious here. That's fine. Not ready yet for letter B. Let's go to letter C. Between 0 and 60, must there be a time when velocity is negative 5? Ooh, I love that one. Which one is this? Not mean value. You're close. Intermediate. Letter C is intermediate value theorem, guys. It says between 0 and 60, must there be a time t when the velocity is negative 5? Well, look at it. Remember that velocity is continuous. Yeah, and it also tells you it's continuous. Notice that at 35, you're at negative 10. And at 50, your velocity is 0. Did I cross negative 5? You had to. There's no other way. There's no way you can go from a negative 10 to 0 without hitting negative 5. Does that make sense? What theorem is that? That's intermediate value theorem. So all you say for that one, you say, yes, by IVT between 35 and 50, there must be a value where velocity is negative 5. No, you just write, how would I solve this one? I would write V of 30 equals negative 10. And then V of, which one was the other one? The one that says 0? 50. Oh, and it wasn't 30, it was 35. How come you guys didn't fix me? V of 35 equals negative 10. V of 50 equals 0. And then I would go IVT. And then I would say, yes, there must be a time t. And in the parentheses, I will say where t is between 35 and 50. And then close parentheses, where. Because between 35 and 50 is where I know for a fact I crossed negative 5. Do you know what I mean? You can also, they probably call it C. There must be a time C. So let's put the letter C. Because T is general for time. And C is specific for some specific time. Where V of C equals negative 5. And then I would put comma IVT. There. Full credit. Should we look at the rubric? What year did I say this was? 2006 Form B. All right. I haven't seen the rubric in a long time, guys. So let's see how we do. Let's see how we did. Don't look at letter B though, because it's gonna ruin the magic. Maybe try really hard not to look at it. Free response. College Board. Free response. BC. Oh, that's not a BC question. That's an AB, right? 2006. Oh no, that's just gonna tell me the questions. Scoring guidelines. I'm very organized when it comes to my digital notes here.
Yeah, you have a lot of folders that's like full.
Yeah, 'cause I got a lot of stuff. I'm hardcore.
And if you were to get a new computer, would you have to transfer all of that?
No, it's all in the cloud. It's all in the OneDrive. All right, here it is. Oh, each free response question is worth 9 points. Your job is to get at least 4. If you didn't get 4 to 5 on each one, you're in good shape, or a decent shape. Letter A, the integral between 30 and 60. Let's see what the rubric says. The integral between 30 and 60, absolute value of t dt, is the distance in feet that the car travels from t equals 30 seconds to t equals 60 seconds. You got to give me that interval, because without that interval, you're not going to get the point, guys. It means a distance traveled within that time interval. So I like the way they wrote it. They did it the way I did it, but I actually prefer the word interval in there, but that's fine. Trapezoidal approximation, look at this. They have the exact work that you guys did, and then they put equals 185 feet. If you didn't do the 185, you still get the full credit. How many points? 3. Oh, sorry, 2. I can't. 2 points. Don't worry about letter B. We will talk about letter B when we get there. Oh, there was a letter D, but good thing I took it out. Was letter D? Yeah, because we're not ready yet, because we didn't do letter B. All right, letter C. Letter C says between 0 and 60, must there be a time when velocity is -5? Justify your answer. So let's see. Letter C. Yes. Oh, I don't like no, I don't like that. This rubric does not mean that yours has to look like that. I do not like that. I like this in the middle. I do not like this. Yes, since velocity of 35 is -10, which is less than -5, which is less than 0. Yeah, all these are true. And 0 is velocity of 50. The IVT guarantees a t between 35 and 50, so that v of t is -5. I like my answer better. I don't like their answer. How many points was letter C? 2. Notice that they give you a point for saying, oh, it's between this interval. It doesn't have to be that exact interval. You could have said negative at 0 and at 50 at 0. Like, you have to mention, like, the -5 is between these two numbers. It doesn't have to be that exact one, but it has to be -5 is between one of these two. Does that make sense? So you could have said v of 0 is -20, v of 60 is 10. And that would have been correct as well. Does that make sense? They're just being exact. Like somewhere in here, somewhere between the 35 and 50, it happened. But you don't have to use that one. You could have used even more further. As long,
Say 0 to 25.
you just have to make sure that that whatever numbers you use, -5 is in the middle, right? That makes sense, guys? And there it is. So they gave you 2 points. Yes refers to IVT or hypothesis. Yeah, I know I said it a little weird there. How do we feel?
Do we have to write it in the form that they have it?
No. No, mine's full credit. Let's see, where is it? V of 35 is -10, V of 50 is 0. Yes, there must be a time C between 35 and 50 where V of C is -5, comma, IVT. That's full credit. That makes sense?
Yes.
Because I'm letting them know that I already figured out, yeah, all that good stuff. How do we feel, guys? All right, we got 40 minutes. I do have a circuit. How do you guys feel with energy? Let's just see where we are at. You don't have to finish it today. Let me close this here.